Hi. Attention. So, what are the main components of the attention? The first is embedding, second is key, and query, and so on. So, first, what we do is we embed our data into some embeddings, means we bring whole data into some space, and then key, query, and value are the matrices which will decide the relationships between those data points that you have encoded with encoding. And if we want to change the meaning or as per the context of some data point and so on, so this goes on like how do we relate different data points. And then MLP is there for a one thing that we'll discuss. And then we also have a softmax there, which will give us a probability in the end. And then we have multi-head attention. So once we have embedded our data point, what will happen is we will have a query function, which will be having a dimension of low rank dimension than the embedding. And then it is some sort of a question like, is the next word adjective or not? And then for the key is like answering that question if I am an objective over there or not. So what we do here is, for example, if I have word one here, word two, word three, and so on, and here again I have word one, word two, word three of a sentence, which is something like this, then and this is say my key and this is my query, then I will have a dot product here for this W1 and W1, W1, W2, and so on. So once we have those embeddings in here, what we really want is, depending upon the problem, for example, if we just want to predict W4 here, what will happen is that you do not want the W4 presence to the alter the data points which are there in W1, W2, and W3. So what we do is we mask this and we put these low rank to the 0, okay? And in case of the application of translation, where W4 position word can impact the previous word position, so then we do not mask, okay? So once we have key and query, and we know that how the things are going on, then it comes the value matrix over there. In the value matrix, value matrix is in the embedding space, meaning it's a large matrix which can be decomposed into two low rank matrices. So what this does is it brings down the embedding into a low rank space, and then it transforms over there. For example, if you have a train data sample here, and I say that there is a Hogwarts nearby or a Harry Potter nearby that train word, then you would try to translate it to the you would like a delta E in that embedding, so that now it corresponds to more of a Harry Potter related features, like maybe flying in the air or something. So that is the delta E that we are looking for, that how to change the data point or the embedding data point as per the context. Okay. So then is the multi-head attention, in which we have different sets of key, query, and values. For example, in GPT-3, we have 96 heads, basically 96 key, query, and value sets. So what happens is that we learn delta E from first head, delta E2 from first head until delta E96 in GPT-3. And then all of these embeddings tell that how shall we adjust the position of the data point to make it more reliable in the context and per the task, and we change that into the old embedding. That's it.